All right, Advent of Code, day 11. Here we go. Whoa. All right, seeding system. You're playing lands with plenty of time to spare. The final leg of your journey is a ferry that goes directly to the tropical island where you can finally start your vacation. As you reach the waiting area to board the ferry, you realize you're so early no one else has arrived yet. By modeling the process people use to choose or abandon their seat in the waiting area, I'm pretty sure you can predict the best place to sit. Quick map of the seat layout. So this is our grid. Seat layout fits neatly on grid. Each position is either floor, period, empty seat, L, or an occupied seat, £. For the initial seat layout might look like this. Now you just need to model the people who will be arriving shortly. Fortunately, people are entirely predictable and always follow a simple set of rules. All decisions are based on the number of occupied seats adjacent to a given seat. One of the 8 positions immediately up, down, left, right. If the seat is empty, and there are no occupied seats adjacent to it, the seat becomes occupied. Seat is occupied in form where are occupied, seat becomes empty, otherwise does not change. Floor never changes, seats don't move after one round. Okay, after the second round. The chaos stabilizes, you count 37 occupied seats. How many seats end up occupied? All right, so it's just game of life. All right. Loop do next grid equals this. Any changes equals false. Break if not any changes. Grid equals next grid. OG grid equals grid. Puts how many seats end up being occupied? Put grid dot values dot count s equals £. Okay. Height dot times do y, width dot times do x. Num near, num let's see. If grid x y equals dot, next grid x y equals dot, continue, or next. Occupied equals grid x y equals £. Num occupied equals 0. Do dx dy. Next if dy equals 0. If grid x plus dx, y plus dy equals num occupied equals 1. And then if occupied else, if it's occupied, next occupied equals if num occupied for false, true, false. If occupied not equal next occupied. Any changes equals true. Next grid x, y equals next occupied. Do 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 do. Puts print dot. Okay, that did not work. Oh. Next equals occupied. 71. That's not right. If a seat is empty, if not occupied, and there are no occupied seats adjacent to it, it becomes occupied. If the seat is occupied and 4 or more adjacent seats, oh, it becomes 35. Okay, it's making progress. All right, how can I make this faster? See ya. All right, it's making progress, but how can I make this faster? Or do I just continue to wait it out? Oh, actually, does that matter? $37. Okay, yeah, still correct. 2178. All right, 138. We're doing well. As soon as people start to arrive, you realize your mistake. People just don't just care about adjacent seats. They care about the first seat they can see in each of those 8 directions. Now, instead of considering just the 8 immediately adjacent seats, consider the first seat in each of those directions. For example, the empty seat below would see 8 occupied seats. The leftmost empty seat would only see 1 empty seat. The empty seat below would see no occupied seats. People seem to be more tolerant than you expected. It now takes 5 or more visible occupied seats for an occupied seat to become empty. rather than 4 or more. Empty seats that see no occupied seats become occupied. Okay. Scene equals false while grid dot key x plus dx, y plus dy. Break. Scene equals true. Break. Num occupied plus equal 1 if scene. X plus equal dx, y plus equals dy. And then we need to save this. Ox equals x, oy equals y. $71. Ooh, that did not work. Oh, and then 5. If not occupied, num occupied is 0, then it's true. Otherwise false. If it's greater than equal than 5, oh. The first seat they can see. Seat equals seat. Break if seat equals L. What? Scene equals false. The first seat they see. The leftmost empty seat would only see one empty seat, but cannot see any of the occupied ones. Okay, yeah, so it's the first seat. Oh. Oh, wait, no, this is right. $71. Print. So everything became occupied. Puts X, Y, num occupied. It's always 0. $23, $26. That's weird. Oh. Okay, what is happening to my map? Grid XY. Oh no. Wait. Oh, that's not what I wanted. Next grid. What? Signing. So everything is getting assigned to. What? Okay, it starts out fine. Is this like a reference to it? No. Okay, it is nil. If next occupied. What? Man, I have no idea what's wrong. Puts grid dot inspect. Zero one zero two zero. Zero one zero two. Zero one. Wait, X. Yeah, why is there only oops. Cx equals X, Cy equals Y. Okay, that worked better, but I still don't know what's up. Okay, so they all get occupied. Interesting. If x equals 0, ox equals 0, and oy equals 0, 1, 2, 3, 4, 5, 6, 7, 8. Five? Oh. Okay, here we go. Okay. Man, I don't know what this issue was. This like Ruby scoping issue. But I think hopefully this is correct. Yay. 643 though, brutal. Okay, I don't know what the heck happened. Let's first check the leaderboards. Dang, Zorankiewicz, you're at it again. How'd you do it? Man, you must have been up there. 604? Dang, 29th? And then 1240? Dang, congrats. How did I do on this one? Not super well. Man, what the heck was this issue with oh, okay. The issue, this was my critical error. I just wasn't assigning to this value right away. Okay. There was no weird Ruby scoping errors. I just wasn't initializing my starting point each time in this inner loop. And so I was like checking, all right, what if we go up and to the right? And then what if we go up? But I was actually doing, okay, what if we go up and to the right? And then what if we go up? And then what if we go up and to the left? And then what if we go left? And then down? So that was my issue. Dang. Let's get rid of this grid printing. And then it's very slow. How many iterations is it? But it works. Def. Let's make this print out both things. Def iterate iterate seeding immediate neighbors immediate only bool immediate only and too many neighbors So then this is too many neighbors, and we also just always break if immediate only. Grid. Return grid dot values puts part one, what did I call it? Iterate seeding, grid, immediate only, true, too many neighbors, 4. False, 5. Does that work? All right, so what happened here? Day 11 seeding system. Is this working? Oh. Puts print dot. All right, day 11 seeding on the EX1. 37, 26, yeah. Okay. Seeding system. Your plane lands with plenty of time to spare. The final leg of your journey is a ferry that goes directly to the tropical island where you finally start your vacation. As you reach the waiting area to board the ferry, you realize you're so early, nobody else has even arrived yet. By modeling the process people use to choose or abandon their seat in the waiting area, you're pretty sure you can predict the best place to sit. You make a quick map of the seat layout, your puzzle input. The seat layout fits neatly on a grid. Each position is either floor, an empty floor, period, empty seat out, or an occupied seat, £. For example, the initial seat layout might look like this. There we go. Now you just need to model the people who will be arriving shortly. Fortunately, people are entirely predictable and always follow a simple set of rules. All decisions are based on the number of occupied seats adjacent to a given seat. So we're basically running like a modified game of life with like a couple extra states. Following rules are applied to every seat simultaneously. If it's empty and there are no occupied seats adjacent, the seat becomes occupied. If the seat is occupied and there are 4 more adjacent seats to it, the seat becomes empty. Otherwise, it doesn't change. And then eventually it stabilizes. And so we want to know how many seats end up occupied. So we do that. Then how we actually solve this is we have our grid, which is actually a hash from 2D arrays with X and Y to values, which is a very inefficient way, which is why this is so slow. And we get the height and width. Then we're going to iterate the seating we take in our grid, and we're going to loop, and we create our next grid. And then we'll say there are no changes. We loop over every location. If it's a dot, there's no seat there, and so it keeps being a seat. Otherwise, we figure out whether it was originally occupied. Let's do this. So we count how many neighbors are occupied. And so we iterate over all the deltas, -1 to 1 in both x and y directions. We skip if we're not going in either direction. Then we get the current x and the current y. And then this is sort of, I'll do it this way. If immediate only, else. This is what we want. So if we're only considering immediate neighbors, if grid cx, I'll put this up in here too. Grid x plus dx, y plus dy equals occupied. Then num occupied plus equal 1. Yeah, if the neighbor is a £, that means it's occupied, and so we increment our counter. Then we get whether the seat was originally occupied. If it's originally occupied and there are too many neighbors, then it's not occupied. Otherwise, it stays the same. If it's not occupied and there are no neighbors, then it becomes occupied. Otherwise, it stays unoccupied. So then if the previous occupied value does not equal the new one, there were changes. And then if it's now occupied, we set it to the £, or an L. We break if there are any changes, update our grid. And then at the end, we count how many keys in our grid are equal to the £, which tells us how many seats are occupied. Then for part 2, the only difference is that people care about the first seat they can see in the directions, not just the immediately adjacent one. And so what we do in this case is we start at our current location, and this was like the critical line that I forgot and lost like 15 minutes on. So while there's something in that direction, we get the seat value. If it's equal to, if it's an empty seat, we stop because it's the first seat they can see. And we have the scene variable, which is false. But if we see a £, then we have seen something and we break. And then we increment our indexes. And then if we saw anything, we increment our occupied. And then the other bit is just the too many neighbors is changed from 4 to 5 in part 2. And so was just one other thing that I had to change. Yeah, so that's day 11. Git add December 11. December 11th, 2020 solution. Yeah. So my grid input is a hash from 2 element arrays, which is really inefficient. So I think I'm going to update my grid input to actually return in an array of arrays. And then maybe just have a way to automatically create empty grid and copy a grid. Because if this is just a grid, all of these lookups are way faster, which is good. yeah, I think that's it. I'm not going to make those changes now. I'll make them in a bit. Oh, yeah, I don't want to make that change. All right, that's all for Advent of Code Day 11.